Okay, so the question says digit in the units place in the square root of 18496 is. Okay, so for that purpose, obviously we are supposed to find out the square root of this number. Then only we can find what is the unit place of the square root. Okay, so let us find out the square root of 18496. Okay, 18496 can be factorized. Okay, for finding out the square root, we are supposed to factorize 18496, 18496. That is divided by 2. It's become 9. Then 2 2 ja 4. Then it is 2 4 ja 8. 1 8 ja 16. We can again divide it by 2. This is going to be 46 and 24. We can then again divide it by 2. It is going to be 23 and 12. Again divide by 2. So it becomes 2 1 ja 2. 2 1 ja 2. 1 2 5 ja 10. 1 2 6 ja 12. Can divide by 2, so it becomes 2 5 ja 10. 1 2 7 ja 14. 1 2 8 ja 16. Again divide by 2, it becomes 2 1 ja 2, rather 2 2 ja 4. 1 2 8 ja 16. 1 2 9 ja 18. Now 289 is a nothing but the square of 17 only. So instead of again doing the factorization of 289, we can simply write 17 square for 289. So it's going to be 17 into 17. So the factors become, see, how can we find out the under root of that? So let's make a pair of two numbers. So 2 and 2 together. So we'll write 1 2 for it. Okay, into, then 2 and 2 together. So we'll again write 1 2 for it, then 2 and 2 together. So again we'll write 2 for it, 1 2 for it. Then 17 square, that is 289, is present, so we'll write just a 17 for this. So this is going to be the under root of 18,496, which is nothing but 2 2 ja 4 2 ja 8, 17 8 ja is 136. So that is what is the under root of 18,496. And he has asked for the unit digit. So unit digit of this is nothing but the sixth. The digit at the unit place is nothing but 6. So that becomes the right answer for us. Next, what is the square root of 7 plus 3 root 5 into 7 minus 3 root 5? This is what he is asking. Square root of this. So clearly we are supposed to find out the under root of 7 plus 3 root 5 multiplied by 7 minus 3 root 5. So we are supposed to find out the under root of this. Okay, so obviously we can use the formula that a plus b into a minus b. We can use the formula of this. A plus b into a minus b is nothing but a square minus b square. So using this formula, we can treat the question like a plus b, 7 plus 3 root 5 into 7 minus 3 root 5 is going to be a square minus b square. That is 7 square minus 3 root 5 whole square. This is what it is going to be. Okay, if we solve it, this is coming out to be 49 minus 9 5 is 45. Okay, which is nothing but under root of 4, which is nothing but 2. So ultimately the square root of the expression given is just 2, which is available in option number C, becomes the right answer. Next, if 5 plus 2 root 3 over 7 plus 4 root 3 is equal to a plus b root 3, then we are supposed to find out the value of a and b. So let us write the left hand side first. What says the left hand side? Left hand side is 5 plus 2 root 3 divided by 7 plus 4 root 3. So to simplify this left hand side, what we are supposed to do? We are supposed to do the conjugate of it. Okay. What is conjugate? Denominator's reverse sign. Okay. That is what is conjugate. Denominator's reverse sign. So it's going to be multiplied by 7 minus 4 root 3 and then also divide by 7 minus 4 root. So we have done the conjugate of the denominator, that was 7 plus 4 root 3. So if we solve this further, so on the numerator side we are getting, if we multiply 5 7 is 35 plus it's going to be 14 root 3, 7 2 is 14, minus 20 root 3, we are just multiplying, minus 24 divided by, now on the downside you can see it is going to be a plus b, a minus b, and a plus b and a minus b can be treated as a square minus b square, that is nothing but 7 square minus 4 root 3's whole square. If we solve this further, this is coming out to be 35. This is coming out to be ultimately 11 minus 6 root 3. This is what it is coming out to be finally, 11 minus 6 root 3. If we compare this thing with the right hand side, that was a plus b root 3. So clearly we can find out in place of a is 11 and in place of b is what? Minus 6. So clearly we can say a is 11 and b value is nothing but minus 6. This is available in option number B. So becomes the right answer for us, A11, B minus 6. Next, they say find the value of the whole expression given like that. So clearly, if you see the numbers, 512 is nothing but the cube of a very famous number. Okay. Similarly, we can find out the 0.04 can also be treated as a square number. So let us just simplify this expression further. How we can do that? Let us quickly remove these decimals. Okay. How we can do that? In place of 0.000512, what we can write is, see, obviously there is a cube root thing there. There's a cube root thing there. In place of 0.000512, we can write just 512 divided by 10 lakh. Okay. 10 lakh. This can be written like that. This 0.000512 can be written like this. Okay. And there was an under root of this done. And then this is divided by 0.04. Clearly 0.04 can be written as 4 by 100. So this is the numerator side. Okay, let's see the denominator side. In the denominator, we have 729 and that is in decimals. Okay, so in place of this 0.000729, what we can write is this is just the under root. So we can write 729 divided by the same 10 lakh. Okay, same 10 lakh can be written here. Divided by, it becomes 3 by 100 because 0.003 can be written as 3 by 1000 rather. 0.0003 can be written as 3 by 1000 rather. So let us just quickly try to solve this. What is the first one becoming? So if you see 512 is going to be the cube root. Okay. So 512 is going to be the cube root. Okay. So if we solve this further, this 4 by 100 can be cut as 1 by 25. And this 5 by root 5 by 512 by 10 lakh is a cube root. Similarly, 729 is the cube root of your 9. Okay, 79 is the cube of 9. So this is going to be 9's cube and divided by the 100's cube itself. So we can simply solve it. If we solve this further, this particular expression is finally getting to solve as 2 by 9. Okay, so that becomes the right answer. By simplifying this into the hundreds and thousand by removing the decimal, the things are easy to solve. So this is what it has become. 2 by 9, which is available in option number C, becomes the right answer. Okay. Question number 5. The value of 0.4 times 0.4761 is. So clearly, we'll have to keep writing that in the non-decimal form first. For doing that, what we can do is in place of in place of under root of 0.00004761, what we can write 4761 divided by 10 to the power 8. This is what it can be written as 10 to the power 8 at the whole under root. Okay. Now let us see what we can do. 4761 is the square of something. 4761 is nothing but the square of 69 itself. Okay. So this under root 4761 can be written as just 69 divided by 10 to the power 8. So 10 to the power 8's under root is going to be always 1000. So clearly we receive the answer as 0.0069. That is the right answer. Okay. Let's have the next one. X equal to 2 plus root 5 and y equal to 2 minus root 5. Find the value of x square plus y square. This is what is the question. Okay. So let us just find out x square plus y square. Okay. X square is nothing but 2 plus root 5's whole square plus y square is nothing but 2 minus root 5's whole square. So we are supposed to do this x square plus y square. Okay, if we solve this further, a plus b's whole square is nothing but a square, so that is 4, plus b square, that is root 5 square, that is nothing but 5, plus 2ab. So it is going to be 2 into root 5, that is nothing but 4 root 5. Okay, plus a minus b whole square is a square plus b square minus 2ab. So a square is 4 plus b square is root 5 square, that is 5 minus 2ab. So 2 into root 5, that is again 4 root 5. Okay, if you simplify this further, this is going to be 9 plus 0 because 4 root 5 and minus 4 root 5 get cancelled, plus 9 again. So we are reaching it to 18. So that is the final answer. Question number 6 has got the answer as option A, 18. Now, the least perfect square which is divisible by each of 21, 36 and 66 is. Okay, so first of all we'll have to find out that particular number which is least in the strength and is the common multiple of all these numbers 21, 36 and 66. So let us try to find out the LCM of 21, 36 and 66. Okay, 21, 36 and 66. For that we know we are supposed to divide them. If we divide by 2, so 21 will not be divisible. It will become 18. This is 33. Let us divide by 2 again. So it's going to be 21. It's going to be 9. It's going to be 33. Let us divide it by 3. So it's going to be 7. It's going to be 3. It's going to be 11. Then it is divided by 3. So it's 7, 1, 11. Then will be 7. And then will be 11. Okay, this is how it will be. So 2 times, 3 2 times, then 7, then 11. So that is what is the least common multiple of the 21, 36, 66. Okay, which is nothing but 2 into 2, then 3 into 3, then a 7 alone, and then a 11 alone. This is what is the least common multiple. He said the least perfect square. So in this particular range, I have to find out the perfect square. So obviously these two are repeated 2 times. So obviously this is a square thing. 3 are repeated 3 times. So again a square thing. But this 7 is alone and this 11 is alone. So this LCM will become a perfect square only when you multiply the whole expression by one more 7 to make a pair of 7, like the pair of 2 and 3 already made. Similarly, again the whole expression will be multiplied by 11 also, so that 11 also achieve its pair. Okay, so clearly the required number is going to be 2 square into 3 square into 7 square into 11 square. That is the required number. So how much do we have to multiply? By 77 only, that is 7 into 11, and the product of this becomes 4 into 9 into 49 into 121. Okay, if you multiply this together, this is ultimately coming out to be 213,444. This is what it is coming out to be, 213,444, which is available in option number D. That is the right answer for us. Okay, question number 8. The cube root of 8 to the power 4 is, cube root is nothing but 1/3 power. Okay, so we are actually supposed to find out, this is the symbol for cube root. Cube root of 8 to the power 4, that's what we have to find out. So clearly the 8 can be written as in the power of 2 as 2 to the power 3 and the whole power 4. Okay, it's like that, which can be written as 2 to the power 3 cube root, and then a 4 can be copied further. We can always change the power order of the powers. That will not affect the question of yours. Okay, so if we do like that, so obviously this power 3 and the cube root will get cut down. So you already remained with 2 to the power 4, that is nothing but 16, and that becomes the right answer, which is available in option number A. Now, what is the square root of 0.4 bar? Okay, we are supposed to find out the square root of 0.4 bar. For that, we need to solve 0.4 bar. Okay, 0.4 bar can be understood as 0.444444, as many fours are possible. This is what is 0.4 bar means. So let us solve this 0.4444. How many times we can do it? Okay, so this 0.44 can be written as 0.4 plus 0.04 plus 0.004 plus 0.0004. Okay, there are decimal numbers in here, 4, and then so on till infinite. This can be further broken down as 4 by 10 plus 4 by 100 plus 4 by 1000, and like that so on. Okay, similarly let us take the 4 as common, or rather we can take anything as common. Let us take 4 by 10 common only. So we are left out with 1. We are left out with what? We are left out with 1 plus 1 by 10 plus 1 by 100 plus, and then so on like that. So this 1 plus 1 by 10, if you see it clearly, 1 plus 1 by 10 plus 1 by 100 is nothing but a GP. Okay, a geometric progression where the numbers are in a particular pattern. Okay, the product, the difference, the common ratio is common between any two numbers. This is what is GP. So this is clearly a GP in front of you. And when there is a plus thing involved, so we are basically looking for sum of GP till infinite. Okay, sum of GP till infinite. What is the formula for sum of a geometric progression till infinite? Is nothing but A upon 1 minus R, where A is the first term and R is the common ratio. A is the first term and R becomes the common ratio. Okay, here what is the common ratio? Common ratio is nothing but 1 by 10. This is what is common ratio, and A is nothing but the first term, that is 1. So if we use this, you're going to get the final value as 4 by 10 and A upon 1 minus R, 1 upon 1 minus 1 by 10. Okay, which is nothing but 4 by 10 into 1 minus 1 by 10 is 9 by 10. So it's going to be 10 by 9. You can get this 10 and 10 cut, so it ultimately comes out to be 4 by 9. So the value of 0.4 bar is simply coming out to be 4 by 9. Okay, and we are supposed to find out the square root of this. So under root of 4 by 9 is nothing but 2 by 3. So that is what is the final answer, 2 by 3. Okay, the particular question's answer becomes 2 by 3. 2 by 3 is nothing but what? 0.6 bar. 2 by 3, if you divide 2 by 3, you will keep on getting 0.666666666, which can be understood as 0.6 bar, and this 0.6 bar is available in option number D, becomes the right answer for me. Okay. By what smallest number 270 be multiplied so that the resulting number becomes a perfect square? Okay, 270 be multiplied by what number so that the resulting number is becoming the perfect square? So for that we will have to do the prime factorization of 270. Okay, let us do the factorization. If we divide by 2, it becomes 135. Divided by 3, it becomes 45. Then by 3, 15. Then by 3, 5. Then by 5, it becomes 1. So 270 can be written as 2 into 3 into 3 into 3 into 5. This is how the 270 is written as. Okay, so clearly we can see how many pairs are being made. Okay, if you see that the product should be to become a perfect cube, they are asking for the number should be multiplied with such number so that it becomes a perfect cube. For becoming a perfect cube, each factor should be repeated 3 times. Okay, but only 3 is such a factor which is repeated 3 times. 2 is just written 1 time, and 5 is also just written 1 time. So to make it a perfect square, we'll have to multiply this whole term more by 2 square and 5 square also. Then only you will have the triplets of 3 and triplets of 2 and triplets of 5 over there. So clearly the smallest number which the 270 be multiplied to get a perfect cube is the product, this particular number 270 to be multiplied by 2 square into 5 square. So that is 4 into 25, that is nothing but 100. So 270 should be multiplied by 100 to become a perfect cube, and this 100 is available in option number C, becomes the right answer. Okay. If 625's whole square is 390,625, then the value of under root of 0.00390625. That's what they're asking. They are saying 625 square is 390,625. This is the 365 square. We have to use this to find out under root of 0.00390625. So let us start operating this. Okay, if we do on the left hand side, if we divide both the terms by 10 to the power 8, so it's going to be 625 square divided by 10 to the power 8 is equal to 390,625 divided by 10 to the power 8. Why we have done 10 to the power 8's division? So that we can reach to a decimal value of 0.00390625. Okay, now we are supposed to find out the under root. Okay, so let us take the under root on both the sides. If you take the under root on both the side, on the left hand side you remain with 625 divided by 10 to the power 4. On the right hand side, you remain with under root of 0.00390625. This is what you are left out with. Okay, now 625 by 10 to the power 4 is nothing but the under root that we were looking for. Okay, so that is what should be the right answer. 625 divided by 10 to the power 4, which is nothing but 0.0625. 625 divided by 10 to the power 4 is nothing but 0.0625. This particular option is available in option number uh, A, 0.0625. Answer is option number A. Okay, let's have the next one. A man plants 16,641 lilies in his garden in such a manner that there are as many rows as there are lilies. Find the number of rows. Okay, as many rows as there are lilies. So clearly, row into lilies in each row. Row into lily is in each row is the product is nothing but 16,641. Okay, there should be as many number as row as many are the lilies. So clearly R is equal to L. What is this R? Total number of rows. What is this L? Lilies planted in each row. So lilies planted in each row is actually equal to the number of rows itself. So when you multiply these two numbers, then only you will be able to achieve the total lilies over there, that is 16,641. So clearly it is R square is 16,641. So R value will be how much? under root of this 16641. Okay, so let us find out the 16641's under root. We can do that by prime factorization also. Keep on dividing by 2, 3, 4, and 5, as many as possible. If you do this, you're going to get to reach R value as 129. So that is the right answer. Number of rows to be used should be 129, and which is available in option number D becomes the right answer. Now, what will be the square root of cube root of all this into under root of 2.56? That's what we are supposed to find out. Square root of this. Okay. So let us just write. We are supposed to find out the square root. First of all, we need to write this number. We need to break this number into some simple numbers. This is how many zeros? 1, 2, 3, 4, 5, 6, 7 zeros. 0, 2, 3, 4, 5, 6, 7 0. Then a 64 multiplied by under root of 2.56. Okay, this is what is the number available to us whose square root is to be found out. Let us suppose try to simplify this number. This whole number can be written as cube root of 64 by 10 to the power 9. Okay, similarly, this 2.56 can be written as under root of 256 by 100. Okay, this is what we can write that. If we solve this further, cube root of 64 is nothing but 4. So it will be 4. Cube root of 10 to the power 9 will be nothing but 1000, that is 10 to the power 3, into under root of 256 is nothing but 16. Under root of 100 is nothing but 10. So this is what I reach to. Okay, which is nothing but, if you solve this together, this is coming out to be 0.0064. We could have written this as 64 divided by 10,000, which is nothing but 0.0064. Now, I was supposed to find out the square root of this. So, I am supposed to find out the square root of 0.0064, okay, which can be written as 6 under root of 64 divided by 10,000, okay, which is nothing but 8 by 100, and it's nothing but 0.08. So that is what the required square root 0.08, which is available in option number B, and becomes the right answer for me. 14. Given root under root 1 plus 55 by 1729 is equal to 1 plus x by 27, then x equal to, I'm supposed to find out the value of x. So let us just quickly write this. He is asking for under root 1 plus 55 by 729 is equal to 1 plus x over 27. Okay, let us try to solve the left hand side first. If you solve the left hand side, you reach to 729 plus 55 divided by 729 is equal to 1 plus x by 27. If you solve this further, this is coming out to be under root of 784 divided by under root of 729 is equal to 1 plus x by 1 plus x by 729. Okay, 1 plus x by 729, 1 plus x by 27 rather. Okay. Okay, so the question says under root of 1 plus 55 by 729 is equal to 1 plus x by 27, then x value is to be found out. So as they say, 1 plus 55 by 729 is equal to 1 plus x by 27. Okay, and we are supposed to find out the x. So let us simplify the left hand side. What is happening in the left hand side is, let's take the LCM. LCM value is 729. So it's going to be 729 plus 55, okay, is equal to the, as it is right hand side, which comes out to be under root of 784 divided by 729. Okay, this is going to be 1 plus x by 27. 784 is nothing but the under root of 28. So we can write it as, not under root, we can write it as 28 divided by, and 729 is under root of 27, square of 27. So that is the under root 27 is equal to 1 plus x by 27. We can bring down this one on the left hand side. So we can get x by 27 is equal to 28 by 27 minus 1. Okay, if we solve this further, we getting x by 27 is equal to 1 by 27. So clearly x value is coming out to be 1 as the right answer. The x value is coming out to be 1, which is available in option number D becomes the right answer. Okay, under root of 10 plus cube root of x equal to 4, then what is the value of x? As the question says, under root of 10 plus cube root of x is equal to 4, then what is the value of x? So for finding out of x, we are supposed to first remove this under root and cube roots. For that thing, we have to remove this first bigger under root. For that, we have to square both sides. So squaring both sides, if we do square both the sides, so we're going to reach to 10 plus cube root of x is equal to 16 on the right hand side. Okay, now let's just quickly solve it. Cube root of x is going to be 16 minus 10, that is 6. So to find out x, we have to do the cube on both the sides. If you do the cube on both the sides, x is equal to 6 to power 3, which is nothing but 216. So that is the right answer. X value is nothing but 216, available in option number B. Next, the approximate value of under root of 1 plus under root 0.01 over 1 minus under root 0.0 is. Okay, we are supposed to forgive them the approximate value of this. So let us write it once. 1 plus under root of 0.01 divided by under root divided by 1 minus under root of 0.1. So let us just quickly find out. So clearly under root of 0.01 is nothing but 0.1. So on the numerator we get 1 plus 0.1 divided by what are we getting in the denominator is 1 minus under root of zero point 0.1. Under root of zero point 0.1 we are supposed to find out, which is nothing but under root of 1 by 10, which is nothing but 1 by root 10, and the root 10 value, if you, so 1 upon root 10 is the final thing because the root 10 value is nothing but it's going to be 1 over 3.1627 something something, and this 1 upon 3.1627, if we divide, we reach to 0.361 something something. So in place of under root of zero point 0.1 we can write what, 1 minus 0.361. Okay, if we solve this further, this is becoming 1.1 divided by 0.684. Okay, 1.1 divided by 0.684, if we divide this, we are reaching to the final value as 1.6, approximated value, and this particular approximated value of 1.6 available in option number B becomes the right answer for us. Okay, question number 17. Now what they say, simplify 4 plus root 5 over 4 minus root 5 plus 4 minus root 5 over 4 plus root 5 plus root 5 minus 1 over root 5 plus 1. So in this situation, when we have got the under root on the denominator side, we are supposed to conjugate the terms. Okay, so we have three such terms separated by plus, in which the denominator has got an under root. So we'll have to conjugate each. So let us conjugate each. The first term is 4 plus root 5 divided by 4 minus root 5. To conjugate this, we'll have to multiply this by the conjugate of the denominator, that is 4 plus root 5 over 4 plus root 5. Okay, if you solve this further, how much this become? On the numerator side, it is visible that it is a plus b, that is a plus b's whole square. So it's going to be 4 plus root 5's whole square. On the denominator side, you can compare this with a minus b and a plus b, a minus b and a plus b, a minus b, a plus b is nothing but a square minus b square. So clearly we have to do 4 square minus root 5 square, which is nothing but 16 minus 5. So ultimately let us open the whole square. 4 plus root 5 whole square can be opened as a plus b's whole square, which is nothing but a square plus b square plus 2ab. So if you open this perfect square like that, it's going to be 16 plus b square is 5 plus 2 into a into b, that is nothing but 2 into 4 into root 5 divided by 16 minus 5 is nothing but 11. Okay, so ultimately we are reaching to a value of, this is becoming equal to 21 plus 8 root 5 divided by 11. 21 plus 8 root 5 divided by 11, this is the value of the first term itself. Okay, this is the value of the first term itself. Let us do the same thing for the second term, which was 4 minus root 5 divided by 4 plus root 5. We'll have to do the conjugate, so it has to be conjugated with 4 minus root 5 divided by 4 minus root 5, conjugated like that, which is nothing but going to be 4 minus root 5's whole square divided by a plus b, a minus b, so it's again going to be 16 minus 5, that is 11 only. A minus b's whole square can be opened as 16 plus 5 minus 2 into 4 into root 5. Okay, divided by 11, which is coming out to be 21 minus 8 root 5 by 11. Okay, this is the resultant second term. Let us go to the resultant third term. Okay, the third term which was given to us was root 5 minus 1 over root 5 plus 1. Third term is root 5 minus 1 over root 5 plus 1. Okay, we'll have to do the conjugate. For that, we have to multiply it by root 5 minus 1, root 5 minus 1. Okay, if you do that on the numerator side, it is a minus b's whole square again, which is nothing but 5 plus 1 minus 2 into root 5 into 1 divided by a plus b. A minus b is nothing but a square minus b square. So it's going to be 5 minus 1, which is nothing but 4, and which clearly comes out to be 6 minus 2 root 5 divided by 4. 6 minus 2 root 5 divided by 4. This is what is the third term coming out. Now we have three terms over here. Okay, if you see it carefully, we have got three terms over here. 21 plus 8 root 5 by 11. This is the first term. This is the second term, and this is the finally the third term. They all were separated by a plus. So let us just keep on writing their values. Okay, if you write their value, it's going to be 21 plus 8 root 5 by 11 plus 21 minus 8 root 5 by 11 and plus the last term is 6 minus 2 root 5 by 4, 6 minus 2 root 5 by 4. So clearly we are supposed to solve this equation. If we solve this together further, then ultimately the LCM is going to be 44. And if you multiply this together, this is coming out to be 234 minus 22 root 5. Both these numbers can be cut by 2, and this 44 can also get cut by 2. So it remains 117 minus 11 root 5 divided by 22. So that is the final answer, 117 minus 11 root 5 by 22, and this particular option is available in option number A. So it becomes the right answer, option number A. Okay, next. The product of 1 minus 1 by 2 square, 1 minus 1 by 3 square, and then so on we are supposed to find out. So clearly we need to manipulate this particular term, because in a simple mathematics way, this is difficult to find out like that. So let us try to manipulate this. See, as we know, a square minus b square is always a plus b multiplied by a minus b, as it is like that. So we're going to use the same fact for the first term, that is 1 minus 1 by 2 square, which can be written as 1 square minus 1 by 2's whole square, which can be treated as a square minus b square, which will give us 1 plus 1 by 2, and 1 minus 1 by 2 will give us 1 plus 1 by 2 and 1 minus 1 by 2. Okay, now similarly this can be done with 1 minus 1 by 3 whole square also, which will give us 1 plus 1 by 3 multiplied by 1 minus 1 by 3. Similarly, 1 minus 1 by 4 square will give us the same term. So clearly the whole series can be rewritten as 1 plus 1 by 2, 1 minus 1 by 2, then 1 plus 1 by 3, then 1 minus 1 by 3, then 1 plus 1 by 4, then 1 minus 1 by 4, and this will last till 1 plus 1 by 12 and 1 minus 1 by 12. This will last till 1 plus 1 by 12 and 1 minus 1 by 12. This is what is the whole series goes. Okay, let us take it down further. Now, what we can do with it? Okay, now let us just separate some more things. Okay, what we can do first, in the first we'll keep on writing uh, the 1 plus 1 by 2, 1 minus 1 by 2, 1 plus 1 by 3, 1 minus 1 by 3. Let us try to find out their values. Okay, so the first value is 1 plus 1 by 2 is nothing but 3 by 2. Okay, then it is multiplied by 1 minus 1 by 2 is 1 by 2. Okay, then it is multiplied 1 plus 1 by 3 is 2 by 3, 1 minus 1 by 3, 1 plus 1 by 3 is 4 by 3, 1 minus 1 by 3 is 2 by 3, 1 plus 1 by 4 is 5 by 4, 1 minus 1 by 4 is 3 by 4. So it's going to be like that till 1 plus 1 by 12 will be 13 by 12, and 1 minus 1 by 12 will be 11 by 12. So it's going to be like that till the last. So in this particular series, let us separate the terms. Okay, what we're gonna do, we will multiply a few things together, and we'll multiply the other things at a different way. Okay, so we'll keep on writing for, so that we can cut as many things as possible. Okay, so we can, in place of this, what we can do is we can write 2 by 3 into 4 by 3 into 5 by 4 into dot 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 till 13 by 12. If we take it like that, 2 by 3, 4 by 3, what we are doing is we are taking 2 by 3, 4 by 3, then 5 by 4 together, till the value of 13 by 12. This value ultimately reaches to 13 by 2. This value ultimately reaches to 13 by 2, because the things will get cut together each other. So ultimately you will be reaching to 13 by 2. And if you take the first term had the terms of 1 by 2, into 2 by 3 into 3 by 4. So clearly this 2 will get cancelled 2 here, this 3 will get cancelled 3 here. Similarly, this has to last 11 by 12. So ultimately you will be left out with 1 by 12. So these are the two terms that you will get by separating them. So if you multiply these two terms together, the ultimate answer will come as 13 by 2 divided by 1 by 12. If you multiply these two terms together, the ultimate answer is coming out to be 13 by 24. So that is the final answer of this series, 13 by 24. And this particular answer is available in option number D and becomes the right answer for us. Okay. 19. A gardener wants to grow his 34,638 trees in a square shaped garden, but he finds that he has 42 extra trees. Find the number of trees, the last row. Okay. So clearly, if it is square shaped garden, so and 42 trees have been extra, so these 42 tree cannot be part of the planted trees. So the number of and one more thing, if there it is planted in a square shaped garden, then the each row will contain the similar number of trees as many rows are there. That means trees is equal to rows. Obviously it is going to, the total number should be tree into row, that should be 34638 minus 42. Why minus 42? Because the 42 have left out. So number of trees in each row multiplied by the total number of row, the product should be this much. Here the tree is equal to row, so we can clearly write r square, because t is equal to row. R square is equal to 34638 minus 42, which is nothing but 34596. What should be the r value then? Under root of this 34596. So we have to do the under root of this bigger term 34596. This can be done by prime factorization as well. If you do that, you're going to get the final answer as 186. So number of rows or the number of trees in the last row is equal. That is nothing but 186 is the right answer finally. Okay. 20. If x equal to 7 minus 4 root 3, then the value of x plus 1 upon x is. Okay. So x we already know. X is 7 minus 4 root 3. So what will be 1 by x? Will be 1 over 7 minus 4 root 3. To find out this, we can conjugate, because we don't leave the denominator on the under root on the denominator side. If you conjugate this, this is 7 plus 4 root 3 divided by 7 plus 4 root 3. This is how it will be. Okay, so the denominator can be treated as a minus b, a plus b, that is nothing but a square minus b square. So clearly it is 7 plus 4 root 3 divided by a square is 49 minus b square is 4 root 3 square, that is nothing but 16 into 3, that is 48. So it is clearly 1. So it is ultimately coming out to be 7 plus 4 root 3. So 1 over x is 7 plus 4 root 3. We are supposed to find out 7 plus 4 root 3. So x is nothing but 7 plus 4 root 3. Rather, x is nothing but 7 minus 4 root 3 plus 1 over x. 1 over x is the value we have achieved of 1 over x is just 7 plus 4 root 3. So we'll have to add it to 7 plus 4 root 3. If you add them together, these two gets cancelled. So ultimately that answer comes out to be 7 plus 7 is 14. Available in option number B becomes the right answer. Okay. By how much does root 24 plus root 32 exceed root 6 plus root 12? So, root 2. So clearly, how much does this exceed the other one? We have to find out the difference. Okay. So clearly, we are supposed to subtract the bigger term and the smaller term. So we have root 24 plus root 32. And how much does this exceed the other term? You can find it out by that by only subtracting. So root 6 plus root 2. That is what we are supposed to do. Okay, let us solve this. Root 24, if you see root 24, if you want to find out the under root of 24, you do the prime factorization. This is going to be like this. Okay, 2 3 ja 6. So clearly it is 2 into 3. So we can write this as 2 root 6. Okay, these two make a couple, so we can just write it 2 times, and then 2 3 ja 6, so it's going to be 2 root 6. Similarly, root 32 2 can be written as 4 root 2. We can see it from here. 32 is nothing but 32 is nothing but 2 to the power 5. So 4 2's can be written together. 2 to the power 4 into 2, and this 2 to the power 4 is nothing but 2 the under root of 2 to the power 4 will be 2 square, and this root 2 will be taken like that. So it's clearly 4 root 2 for root 32 minus root 6 minus root 2. Now 2 root 6 minus root 6 is how much? Is simply root 6 plus 4 root 2 minus root 2. What is 4 root 2 minus root 2? Is nothing but 3 root 2. Okay, so this is the final thing that we get. Answer as root 6 plus 3 root 2 available in option number C and becomes the right answer for us. Next, under root of 0.081 into under root into 0.484 divided by 0.0064 into 6.25 simplifies to what? So clearly we are supposed to find out the under root of them. So now this first term is under root of 0.081. How we can find it the under root? It can be written as 81 divided by 1000. Okay, it can be clearly written as 81 divided by 1000. Okay, and we are supposed to find out the simplification of this. Okay, so 81 is nothing but under root of 81 is going to be your 9, so it's always going to be, and one under root of 1000 can be written as 100 into 10, so that is 10 root 10, so it is always going to be 9 divided by 10 root 10. Okay, similarly we can find out the under root of 0.484. Under root of 0.484 is nothing but going to be under root of 484 divided by 1000 again. Okay, okay, and 484's under root is nothing but 22, so it can be written as 22 divided by 10 root 10 again. And on the denominator side as well, we can find out 0.0064. The under root is clearly again going to be 64 divided by 10,000, that is nothing but 8 by 100. Okay, and similarly we can find out the under root of root 6.25 as well. So if we keep on finding out the under root of all these numbers and we keep on putting them back into the question, what we receive is 9 into 22 divided by 8 into 25. 9 into 22 divided by 8 into 25. If you solve this together, this can be cut by 2 4 ja 8 and 2 11 ja 22. So it's always going to be 99 divided by hundreds. That is nothing but 0.99. So that is the right answer. 0.99 is the real simplification of the expression given available in option number C. Now 23. If x star y, do not take this as multiply, if x star y means x square plus y square plus cube root of xy, then the same fashion we have to find out the value of 56 cube root 56 star y. So clearly 56 will be treated as x and 49 will be treated as y, and there is a star in between. So 56 star 49 can be written as 56 square plus 49 square plus cube root of 56 into 49. This is how we can write out 56 star 49. If you try to solve this further, it's going to be 56 square is how much? Is 3136. Clearly, you can find out the square value. 49 square can be found out as 2401 minus then cube root of 27 that we have to find out. Clearly, the cube root of 2744, that is the product value of 56 into 49, which reduces to 5537, and 2744's cube root is nothing but 14. If you add them together, it comes out to be 5551. That is the right answer, and it is available in option number B. Okay, the sum of 11 squared plus 12 squared plus 21 squared can be what? So clearly this can be solved by a particular formula. The formula is sum of squares of n natural numbers. Okay, sum of square of n natural number. Let me say first n natural numbers is nothing but n into 2n plus 1, n into, it's going to be n into n plus 1, 2n plus 1, n into n plus 1, 2n plus 1 upon 6. That is the formula of sum of square of the first n natural number, n into 2n plus 1 into n plus 1 over 6. Now we have to manipulate this expression further. 11 square plus 12 square plus 21 square. How we can write this as 11 square plus 12 square plus dash 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 till 21 square can be written as 1 square plus 2 square plus dash 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 till 21 square minus, okay, minus what? 1 square plus 2 square till 10 square. So clearly if you see, what we have done is the sum of the perfect square to 21 square minus the sum of perfect square till 10 square will give us the sum of the squares of till from 11 square till 21 square. Okay, now we can use our formula in this first expression. This is clearly being sum of squares till 21 square. Okay, so we can, so n value here becomes 21 for this expression. So it becomes, let us follow the formula. So it's going to be 21 into 2n plus 1, that is 2 into 21. Okay, 2 into 21 plus 1, and n plus 1 is 21 plus 1 divided by 6. That is what is the first expression. Minus the second expression is sum of square till 10. So here n value is 10. So it's going to be 10 into 10 plus 1 into 2 into 10 plus 1 divided by 6 again. If you solve this further together, how much does this become? Okay, if you solve this further together, this is becoming like 21, and then 10 into 10 plus 1, the first term will coming out to be 21 into 43 into 22. 21 into 43 into 22 is nothing but 19,866 divided by 6, minus the next term is 10 into 11 into 21. 10 into 11 into 21 is nothing but 2,310 divided by 6. If you solve this further, this becomes 17,556 divided by 6, which is nothing but 2926. So that is the final answer. Answer is 2926, and let us see where it is available. It is available in option number C. Option number A becomes the right answer for us. Okay, let's have question number 25. Under root of question mark divided by 4 is equal to 1 by 3. What will come in place of the question mark? That is the question itself. Okay, so let us quickly write it. Under root of question mark divided by 4 is equal to 1 by 3. Finding out that, we can clearly say the under root of question mark is 4 by 3, because this 4 can get cross multiplied and go here. So under root of question mark is 4 by 3. So question mark will be squaring both sides, that is 16 by 9. So the square question mark value is nothing but 4 by 3 is whole square, that is nothing but 16 by 9, and it is available in option number B. It becomes the right answer for us. Now the question says under root of 385 plus under root of 211 plus under root of 196. So there are multiple under roots interlinked, and so we have to solve this. So clearly the direct root of 385 is not available. Direct root of 211 is not available. But yes, we know the under root of 196. Under root of 196 is 14. So how we can rewrite this is under root of 385 plus under root of 211 plus, in place of under root 196, what can be written is just 14. So just 14 written here. Now in the next step, what we can do 385 plus under root of 211 plus 14 is nothing but 225, and we know 225 is nothing but under root of 225 is nothing but 15. So it will become under root of 385 plus 15, which is nothing but under root of 400, and under root of 400 we clearly know is the number called as 20. So that is the right answer available in option number D. Answer is 20. Now if root 2 is equal to 1.4142, then the value of 4 plus root 7 divided by 4 plus root 2 is, this is what is required. So clearly we can put up the root 2's value inside, and then we can find out the things. Otherwise we can conjugate that also. So if we conjugate, then we will be able to remove under root 2 from the denominator, but anyhow around we'll have to put the value of under root 2. So this question can be done in two ways. One, and the easy one, will be if we conjugate these numbers, then the under root 2 will not be in the denominator, and the things will be easy. If you do like that, then it is going to be 7 divided by 4 plus root 2, and conjugate of it will be 4 minus root 2 divided by 4 minus root 2. If you do that, this is going to be 7 into 4 minus root 2 divided by 4 plus root 2. 4 minus root 2 is a plus b, a minus b, and a plus b, a minus b is equal to a square minus b square. So that is going to be 16 minus b square, root 2 square is going to be 2. So it becomes ultimately 7 into 4 minus root 2 over 16 minus 2 is 14, and this 7 can cut this 14 by 2. So we are left out with 4 minus root 2 upon 2, okay, which is nothing but, if we divide by this 2 to both the numbers, we're going to reach to 4 by 2 minus root 2 by 2, which is nothing but 2 minus 1 upon root 2. It reaches to 2 minus 1 upon root 2, and clearly we can put the value of root 2 here and we can get the answer. Okay, so if we do that, let us do it here. So it's going to be 2 minus 1 over 1.4142, Okay, if we solve this further together, we are ultimately receiving the right answer as 1.2929. That is the right answer. Okay, and this is available in option number C becomes the right answer for us. Now, the value of under root of 0.03 square plus 0.21 square plus 0.065 square plus 0 point and so on, the things are given like that. We are supposed to find out the answer of this. Okay, so let us start doing it. What we can do, see, if you see it carefully, in the numerator there is 0.03, 0.21 and 0.065. In the denominator it is 0.0065, 0.021, 0.003. So if in the numerator we can make the same term as in the denominator, then obviously we can cut them and it can be easy to solve. Okay, to do that, what we are supposed to do, see, what we can do on the numerator, we can do 0.03, 0.03 square is given, and if you want to make it 0.003 square, then what we'll have to do, we'll have to divide this thing by 100. Okay, but if we divide this by 100, then we'll have to multiply this by 100 as well, otherwise the value will change. Okay, so this is the first thing done. Plus similarly 0.21 divided by, then we have to do 10 here, then again 100, and then we'll have to multiply it by 100 again. Similarly, plus 0.065, we have to again divide by 100 and multiply by 100 as well. Okay, and that whole thing is divided by the 0.003 whole square plus 0.021 whole square plus 0.0065 whole square. Now clearly, now we can, in the numerator what we can do, just give it the thought. In the numerator what we can do, the numerator can now be written as 100 on the outside, and this becomes 0.003 whole square plus this 100 is completely common to all, so it will be 0.021 whole square and plus 0.0065, rather 0.0065 whole square. This will ultimately become, those all hundreds have gone inside and increase the power. Okay, and then divided by, root is bigger, divided by the same 0.003 whole square plus 0.021 whole square plus at the very last 0.0065 whole square. Okay, now we have separated the things, so clearly this particular part can be cut by the part here. So we are ultimately left out with under root of 100, which is nothing but 10. So that is the right answer, 10, which is available in option number, let us see, it's available in option number C becomes the right answer for us. Now question number 29, what they say, if under root of 2 plus x by 196 is equal to 21 by 14, then find out the value for 343 by x. So let us write it down. Under root of 2 plus x over 196 is equal to 21 by 14. So first thing what we do is squaring both sides. Let's square on the both sides. If we do squaring both sides, what we're gonna receive? Okay, squaring both sides. So we receive 2 plus x over 196 is equal to 21 square is 441, 14 square is 196. This is what we receive. Okay, now there is 196 here also and 196 on the other side also. If we try to solve this equation for x, then ultimately what we can do, uh, so this x by 196 is equal to 441 by 196 minus 2. If you solve this further, this is going to be 196 on the LCM side, and this is 441 minus twice of 196, that is nothing but 392. Okay, if we solve this further, x is coming out to be uh, 441 minus 392 only, because 196 and 196 will get cancelled out, and which is nothing but 49. So x value is coming out to be 49. What we are supposed to know? We are supposed to know value of root 343 over x. Let's put this value of 49 in the equation. What do we receive? We receive is under root of 343 divided by 49. Clearly 343 can cut 49 by 7 times, so it has become root 7. So that is the final answer, root 7, and it is available in option number C and becomes the right answer for us. Okay, This is what is the equation that is to be solved. Root 12 square 24 divided by 5. So obviously you have to use board mass here. Okay, we will use the board mass. The rule of board mass says you have to do in the same order, bracket, uh, order, divide, multiply, add, and then subtract. So we'll follow the same order. We'll have to do the divide first. So let us do that. It is like under root 12 square, and the bracket, after bracket there is order means the power. So in place of 12 square we can simply write 144. Okay, that the power has been solved. So 144 plus 24 divided by 5. What is 24 divided by 5? 24 divided by 5 is going to be, not, it is not plus, it is into 24 divided by 5 into 24 divided by 5 is 4.8 minus 6 cube is as it is written 216 plus 149.8. This is as it is written the left hand side. If we solve this further, how much this becomes? This becomes under root of whole thing 691.2 minus 216 plus 149.8. 149.8. Okay, this is what it is. If we solve this further, this is ultimately getting solved to root 625, and on the right hand side there is x square. So under root 625 is x square, so under root 625 is nothing but 25. 25 is equal to x square, so clearly x value is 5. Okay, clearly the x value is nothing but 5, and that becomes the right answer, which is available in option number C, and is the right answer. Okay, question number 31, root 80 minus root 112 over this. This is what is to be solved. Okay, so let us take the under root of 80. So under root of 80, this 80 can be written as 16 into 5. Okay, so under root 80 can be under root of the whole thing, which is nothing but 16 under root is 4. So 4 root 5. This is what is the under root of 80. What is under root of 112? Let us find out. Okay, under 112 can be written as 16 into 7. So clearly under root of 112 is root 16 into 7. That is nothing but 4 root 7. That is under root of 112. How we can write under root of 45? Under root of 45 can be written as uh, 15, can be written as 9 into 5. So under root of 9 into 5 is nothing but 3 root 5. Similarly, under root of 63 can also be broken down as 9 into 7. Under root of 9 into 7 is nothing but 3 root 7. So these are the values that we can replace. Okay, under root 45 can be replaced as 3 root 5. Root 63 can be replaced as 3 root 7. Root 112 can be replaced as 4 root 7, and root 80 can be replaced as 4 root 5. If we do that, the replacement part, so it becomes let's take 4 common in the numerator. So root 5 minus root 7 divided by, if we take 3 in the common in the denominator, root 5 minus root 7 again. Okay, so clearly these two values can cut. So ultimately we are receiving 4 by 3, which in the mixed fraction becomes 1 by 3. Okay, this is what it becomes in the mixed fraction, and that is going to be the right answer, which is available in option number C. Okay, let's have the next question. Find the value of 4 plus root 8 over this. Okay, so clearly we'll have to break this down into some factors. Okay, so let us keep doing that. We have 4 plus root 8 in the numerator divided by, okay, 108. Let us break 108. How we can break 108? 108 can be written as 36 into 3. So root of 108 is nothing but root of 36 into 3, which is nothing but 6 root 3. So this is how 108 can be replaced. Similarly, 2 root 12. 2 root 12 can be written as 2 into root 12 is 4 into 3. That is nothing but 2 into this 4. Under root of 4 is 2. So 2 into 2, that is 4 root 3. So 2 root 12 is written as 4 root 3. Similarly, root of 150. Okay, how can the root of 150 be broken as? 150 can be written as under root of 25 into 6. 25 6 ja 120. So which can be broken down as root of 25 is 5, and then there is a root 6, so 5 root 6. This is how root 150 can be written as. The last value is root 216, and the root is already available. 216 is nothing but, how can 216 be written? This 216 can be written as 6 root 6. Okay, it can be written as 36 into 6, that is 6 root 6. So these are the values that we're going to replace: 6 root 6, 5 root 6, 4 root 3, and 6 root 3 in the expression as it is. Okay, so if we do that, so the expression becomes 4 plus root 8 divided by 6 root 3. minus 4 root 3 minus 5 root 6 or and the plus 6 root 6. Okay, if you solve this further, this further becomes 4 plus root 8, and these things get cancelled out. Divided by 6 root 3 minus 4 root 3 is simply 2 root 3 plus 6 root 6 minus 5 root 6 is nothing but root 6. So this is what it becomes, 4 plus root 8 over 2 root 3 plus root 6. But the answer is given in the single fraction only, so we'll have to conjugate this. For conjugating this, we'll have to multiply it by the conjugate of the denominator. If we do that, what we're going to get, 4 plus root 8 divided by 2 root 3 plus root 6 into 2 root 3 minus root 6 divided by 2 root 3 minus root 6. This is what is the conjugate. Okay, let us solve it a little down. Okay, now if you do this like that, then a plus b, a minus b. So it's always going to be a square minus b square. Going to be known on the numerator side is the simple multiplication. So if we do that, the first thing is 8 root 3 minus 4 root 6 plus 4 root 6 minus 2 root 12. The product part divided by a plus b minus b is a square minus b square, which is 12 minus 6. So it ultimately reduces to 8 root 3 minus 2 root 12 divided by 12 minus 6 was 6. So if we take the 2 common, then we can write it down as 2 root 3 divided by 3. So that is should be the answer. 2 root 3 divided by 3 should be the answer. Let us see the options. 2 root 3 over 3 is available in option number A and becomes the right answer for us. Next, we have to find out the cube root of the following term. So clearly 729 can be broken down into some factors, and the denominator 85,184 is also can be broken down into 85,184 also can be broken down into some factors. So clearly we are supposed to find out the 729. Okay, 29's cube root we already know is 729 cube root we already know is going to be 9, because 9 into 9 into 9 is 729. Similarly, find out the cube root of 85,184. This can be done by trial and error only. Okay, so if you do it by trial and error, you can find out the 85,184 is the cube of nothing but 44. So cube root of that is 44. Now the question is how we are supposed to replace them so that the decimal numbers are also targeted. So obviously this particular expression can be written as cube root of 720 0.0007929 can be the under root, then can be the cube root of 0.09 into 0.09 again and into 0.09 again, divided by, on the denominator, it has to be 0.44 into 0.44 into 0.44. This is how it is. Okay, this is how we can break it down. So clearly, if it is a cube root, so only 9 will come in place. So it can be written as 0.09 divided by 0.44. And if we cut down this number, so clearly the number is becoming 9 by 44. And that is going to be the right answer, which is available in option number B, 9 by 44. Okay, now again we have to find out the cube root of something in the question number 34 available. Let us do that. Cube root of 0.0001 into cube root of 10 lakh divided by cube root of 0.125 divided into cube root of 0.0008. So clearly we note cube root of 0.0001 is nothing but 0.01. Similarly, cube root of 10 lakh is simply going to be value called as 100, and cube root of your 0.125, 125 is the cube of 5, so 0.125's cube root is nothing but 0.05. Similarly, cube root of 0.008, okay, cube root of 0.8 is the cube of 2, so 0.008 can be the cube of 0.2. So let us replace these number in the final expression. If we do that, we're going to get the value as 0.01 into 100 divide by 0.05 into 0.2. If we solve this further together, we are ultimately reaching the value of 10. Okay, the value of 10 is being reached, and that becomes the right answer for us, which is available in option number B is the right answer. Okay, if x equal to 10, then what is the value of all this given? So let us replace the 10 in the expression given. If we do that, so it is going to be 13 into 10 cube under root of 10 cube minus 10 square. This is what it is going to be. If we solve this further, this is coming as 130 under root of 1000. 10 cube is 1000 minus 10 square is 100. Okay, if we solve this further, this is going to be 130 under root of 900. And we clearly know the under root of 900 is nothing but 30. So it is going to be 130 into 30, that is nothing but 3900. So that is the answer, 3900. It is available in option number B. Now, the least 5-digit perfect square number which is divisible by 3, 4, 5, 6, and 8. Okay, we have to find out the least 5-digit perfect square number. So first of all, we'll find out the least number which can be divisible by all three. It clearly indicates that this kind of number is only least common multiple. The least number which is divisible by all three is obviously their LCM. So clearly indicated that we are, first of all, we are supposed to find out LCM of 3, 4, 5, 6, and 8. So there's a very basic technique of finding out the LCM. So let us do that. 3, 4, 5, 6, and 8. This is what the LCM we are about to find out. So let us begin. 3, 4, 5, 6, 8. Okay, let us begin with the basic prime factor, that is 2. 2 cannot divide 3, so we'll just write 3. 2 2 ja 4, 2 5, 2 3 ja 6, and 2 4 ja 8. We can again divide by 2. So it's going to be 3, it's going to be 1, 5, 3, and 2. Again goes by 2, so 3 as it is, 1, 5, 3, and 1. Then let us go with the 3. So this will become 1, 1, 5, 1, and 1. And the last will be 5, which will make all things as 1. So this is what the product of these numbers is nothing but going to be the LCM. And how much is that? 2 2 ja 4, 4 2 ja 8, 8 3 ja 24, 5 ja 120. So clearly the LCM becomes 120. But they have not asked for the LCM, they have asked for the perfect square number, 5-digit perfect square number. So obviously we'll have to keep on multiplying 120 and keep on checking the multiples of 120 till the time we reach the 5-digit. Okay, so 120, clearly if we do the next multiple of 120 only, if we do 120 square itself, it comes out to be how much? 14400, and that is the, this is the first square only. So that should be the answer only, because he had said 5-digit perfect square. 120, it has to be in the chain of 120 only, in the powers of 120 only. And if we just went for the second power itself, that brought out the number 1,44,000, and that clearly is a perfect square and a 5-digit number also. So that's what he was asking in the question. So this is the right answer, 1,44,400, rather 14,400, which is available in option number A. Okay, the largest among the numbers, zero point 0.9, zero point 0.9 square, under root zero point 0.9, and zero point 0.9 bar. So let us try to find out. So we have to find out the largest of 0.9. 0.9. 0.9 square is nothing but, if we do the square of 0.9, that is nothing but 0.81. Under root of zero point 0.9, we clearly know the under root of zero point 0.9. For that under root of zero point 0.9, we have to solve it. Okay, so we are supposed to find under root of 9 by 10, which is nothing but under root of 9 is 3, and under root 10 is 3.61 in a long chain. Okay, so it's going to be 3 by 3.61. If we solve this, if we divide 3 by 3.61, we receive a final value as 0.94, and that is also rounded about. So the third number is going to be 0.94. Let us check the last number, 0.9 bar. So there is a way of finding out the answer for 0.9 bar. There's nothing but 0.9999 till the infinite. Now we have to check which is one is the largest among all these four numbers. So clearly 0.81 is the smallest one, so it is gone. Then bigger than 0.81 is zero point 0.9, so this is not the largest. Bigger than zero point 0.9 is 0.94, this is not the largest. So clearly the largest number is 0.9999 till infinite, which is nothing but zero point 0.9 bar. So that should be the right answer only, available in option number D, 0.9 bar. Question number 38, we have to solve this. Okay, so let us do that. Clearly we are supposed to find out the under root of this. Okay, before we can do it multiple ways. We can find out the under root of 2.25 and 5.76 and 1.44 and 9 separately, and then solve it. Also we can do it by product also. So let us do the product part. 2.25 multiplied by 5.76. If you do the product part of it, the multiply of it comes out to be 12.96. Okay, similarly we have to do the product part of the denominator, that is 1.44 multiplied by 9. If you do this, this again comes out to be 12.96. 0.96. So clearly we can replace these two numbers as the numerator and the denominator. So your expression becomes how much? Under root of 12.96 divided by 12.96, which is nothing but under root of 1, and which is nothing but equal to 1. So that is going to be the right answer. There is another way of it also, that we find out the individual under roots, but that is going to be too much lengthy. So we can go by this. So answer becomes 1. Now, in the 39, he says x equal to as given this, y equal to as given this, then find out the value of x square plus y square. So this question can be done in multiple ways. One way of doing it is clearly do the square of x, clearly do the square of y, and then add. This could be one way, but there can be an easier way also. In that, what we can do, see, if you know the formula of x plus y whole square, or rather a plus b whole square, that is nothing but x square plus y square plus 2xy. This is the formula for x plus y's whole square. In this, if you want to know what is x square plus y square, so clearly you can change the side. So x square plus y square is going to be x plus y's whole square minus 2xy. Okay, so we're going to use this particular formula for finding out our thing. So clearly, if we want to know x square plus y square, we have to go by x plus y whole square minus 2xy. So this is what we are going here. So let us do x plus y. In place of x, I have the first term. In place of y, I have the second one. So if I do x plus y's whole square, this is going to be root 3 plus 1 over root 3 minus 1 plus root 3 minus 1 over root 3 plus 1, and its whole square is to be done by me first, minus 2 into xy. X value is root 3 plus 1 divided by root 3 minus 1 into y value is root 3 minus 1 over root 3 plus 1. Okay, this is what the expression becomes, and clearly it can be seen here. The advantage of doing this trick is this and this gets cut away by each other. Okay, because every value is getting cut like that. Okay, so it is only remaining 2 on the second term. So what I'm left out with, I'm left out with the left part only. So let us try to solve this. Then obviously I can use the a minus b whole squares formula, or I can do the other way also. I can take the LCM also. Let me do it by the simple way. Let me take the LCM. Let me not do the square. So if I do take the LCM of this, then the LCM is clearly root 3 minus 1 into root 3 plus 1. That is going to be the clear LCM. And what I am receiving on the numerator part, so root 3 minus 1, and it divides the whole term. So root 3 plus 1 is left out. So clearly I am receiving root 3 plus 1's whole square plus root 3 plus 1 is here, and the whole term is this. So root 3 minus 1 is the quotient. Root 3 minus 1 multiplies root 3 minus 1 again. So clearly it becomes root 3 minus 1's whole square. Root 3 minus 1's whole square. And there is a minus 2 here. Okay. And there is a minus 2 here. If we solve this further, this is a. We can open this by a plus b whole square and a minus b whole square. If we do that, this is going to be a square is 3, b square is 1 plus 2ab. So 2 into root 3 plus a minus b whole square. So a square is 3, b square is 1 minus 2 into root 3, 2ab, divided by, on the denominator side, what do we have? Root 3 minus 1, root 3 plus 1. That is nothing but a plus b, a minus b. That can be treated as a square minus b square. That is nothing but root 3 square minus 1 square. That is nothing but 3 minus 1. That is 2. So this is 2, and a minus 2 is still going from the right hand side. If we solve this further, 3 plus 1, 4 plus 4, 8, and 2 and root 3 and 2 root 3 gets cancelled out. So we are left out with 8 by 2 whole square, and there was a whole square involved also. 8 by 2's whole square minus 2. If we solve this further, this is going to be 16 minus 2, and nothing but the 14 is coming as the right answer. So this could be one of the way of solving this particular question. Otherwise, if somebody wants to do it by the other way around, that can also be possible, but that will be too much lengthy. This is a easier way of doing. Answer becomes 14, available in option number B. Okay. 40th question. Given that 0.13 divided by p square is equal to 13, then p equals what? So clearly we are supposed to solve this. As they say, 0.13 upon p square is 13. So clearly we are supposed to solve p. So we'll make the equation in terms of p. So p square is going to be 0.13 divided by 13. Okay, this can be solved. If we cut 0.13 by 13, we are receiving it as 0.01. So p square has to be 0.01. So clearly has to be under root of 0.01, and under root of 0.01 is nothing but your thing called as 0.1. So it is clearly the answer is P value is 0.1, which is available in option number C and becomes the right answer for us.